everyone, welcome to my channel Chemistry by ANR. Today's session will be on carbonyl compounds. You know what is a carbonyl linkage? It is C double bonded O linkage which is present in aldehydes, which is present in ketones and which is also present in carboxylic acid having C double bonded O OH linkage. Are they all similar? Or is anything dissimilar about them? Let us explore the concepts. Hello everyone. हमारा आज का जो टॉपिक है वो है एल्डिहाइड, कीटोन्स एंड कार्बोक्सिलिक एसिड, जो कि बहुत ही इम्पोर्टेंट है थियोरी और प्रैक्टिकल दोनों के लिए। पहले तो समझना है कि ये एल्डिहाइड्स और कीटोन्स टुगेदर इसका नाम है कार्बोनिल कंपाउंड्स। एल्डिहाइड्स एंड कीटोन्स आर टुगेदर नोन एज कार्बोनिल कंपाउंड्स। दे आर नोन एज कार्बोनिल कंपाउंड्स। इनको कार्बोनिल्स बोला जाता है, एल्डिहाइड ग्रुप को और कीटोन को। तो एल्डिहाइड क्या है? एल्डिहाइड में ना ऐसा लिंकेज होता है C डबल बॉन्डेड OH, ये है एल्डिहाइड। और कीटोन है कार्बन डबल बॉन्डेड O है और दोनों तरफ R या R' सेम या डिसिमिलर ग्रुप्स है। ये है कीटोन और ये है एल्डिहाइड, ये है कीटोन और ये है एल्डिहाइड फंक्शनल ग्रुप। तो इसका जो नोमेनक्लेचर पार्ट है, इसमें क्या है? लॉन्गेस्ट चेन कंटेनिंग द CHO ग्रुप। नंबरिंग ये CHO ग्रुप से ही स्टार्ट होता है, यही पोजीशन 1 है। इसका सफिक्स जो है वो एल्केन का E को ड्रॉप करके एल आएगा। जैसे फॉर्माल्डिहाइड 1 कार्बन एटम है, मिथेनॉल ये 1 है, मिथेनॉल 2 कार्बन एटम, इथेनॉल 3 कार्बन एटम, प्रोपेनॉल कॉमन नेम है प्रोपायोनाल्डिहाइड, कॉमन नेम इज प्रोपायोनाल्डिहाइड। तो प्रोपेनॉल क्या है? CH3, CH2, CHO, ये 1, 2 and 3 प्रोप सिस्टम एल्डिहाइड। कीटोन्स भी ऐसे होंगे, longest carbon chain containing the carbonyl you have to see and you have to drop the E and bring on in the naming. So let's see, acetone is what? This is 1, 2 and 3. Propan, dropping propane, E. Propan 2 on. This is 1, 2, 3 and 4. So meth, eth, prop, but, butan 2 on, pentan 2 on will be 1, 2, 3, 4 and 5 carbon atom. 2 position there is on. Now fill up the H. CH3, CH2, CH2 and CH3 here. Priority in nomenclature, always remember this, higher priority will be getting lesser number. So this is carboxylic acid is having greater priority than aldehyde, than ketone, than alcohol. That means a compound containing alcohol functional group and carboxylic also, the main functional group will be carboxylic and alcohol ka OH will work as a substituent at that time. So next, like here it will be hydroxy. Okay, lower priority agar hai, then it will be named as hydroxy. So if a compound has both aldehyde and alcohol, the aldehyde gets priority in naming and this alcohol will be acting as a substituent. Okay, cyclic carbonyl compounds, cyclic ketones agar hai, to cyclopentanone, on is getting attached. Cyclic aldehyde agar hai to carbaldehyde, cyclohexane carbaldehyde. What is that? This is cyclohexane ring, with that a CHO is there, so it is a cyclohexane carbaldehyde. Nomenclature of carboxylic acid, you have to number the carbon of carboxylic acid as 1. So numbering will be the carbon of COOH getting 1. Replace E by oic acid. Like over here, let us see. Formic acid is methanoic acid, 1 carbon atom. Acetic acid, ethanoic acid. Propanoic acid is what? Propionic acid. This is the common name. 1, 2, 3. Butyric acid is butanoic acid. 1, 2, 3, 4. Valeric acid is pentanoic acid. So we'll write CH3, CH2, CH2, 3, 4 and 5. This is pentanoic acid. So substituted carboxylic acid. How? So here we'll see that prefix is methyl, bromo, hydroxy as per alphabetical order. So this is something like methyl substituent is there. So 2-methyl propanoic acid. So how to draw the structure? When it is propanoic acid means meth, eth, prop, and first one is oic acid. So this is carbon 1, 2, 3. 2 position there is methyl, so make a methyl here and now fill up with H. CH3, CH will be here and there won't be any H in carbon number 1. Aromatic carboxylic acid, how are they named? They are named as carboxylic acid, like IUPAC name. Benzene carboxylic acid, what is it? It's benzoic acid, right? It's benzoic acid. Benzene carboxylic acid. Now 2-methyl benzoic acid will be what? This is the benzoic acid. This is, say, benzoic acid. 2 position there is a methyl. 4-hydroxy benzoic acid. So here again I'm getting COOH and 4 position there is OH. So these are the structures. Dicarboxylic acid means dioic acid. So oxalic acid is ethane. Here we are naming the alkane completely. See, the alkane is named completely. Ethane, so 1 and 2. Dioic acid. Malonic acid, 1, 2, 3. So propane, dioic acid. Butane will be COOH, CH2, CH2 and COOH. That is succinic acid. Okay. So remember, dioic acids are named as Ohm's gap. They are named as Ohm's gap. Remember this. This is carbon number 2. Total 2 carbon atoms are there. 3, 4, 5, 6, 7. So this is oxalic acid. This is malonic acid, succinic acid, glutaric acid, adipic acid, palmitic acid. So total they are containing 2 to 7 number of carbon atoms. So these are the linkages where you can see that C double bonded O exists. This is aldehyde because there is another H over here. This is ketone because C double bonded O is there, but there is no H. Carboxylic acid has C double bonded O, but this is not a carbonyl. Here again acyl halide C double bonded O, not a carbonyl. Amide C double bonded O, not a carbonyl. So please remember that these two are forming carbonyl compounds. Okay, so aldehydes and ketones are collectively known as carbonyl compounds. So next, this is 1 and 2, ethanal. See, 4-bromo-3-methyl heptanal. Numbering is must, otherwise you are bound to make mistake. So 3, 4, 5, 6 and 7. 4 position bromo, 3 position methyl and 7 carbon atoms in total. Heptanal, 1 carbon atom. Carbon number 1 is CHO. So 3-methyl cyclopentanone. So this is your cyclopentanone in 1, 2 and 3 position. 3 position there is methyl. Cyclohexane with any ring system. Okay, the aldehyde group, if it is present, it is known as carbaldehyde. So over here again 1, 2, 3, 4 and 5. So carbon number 1 is the aldehyde. So pent 2-in-1-al or pent 2-enal. Now this again is 1, 2 and 3. 1 position is having phenyl. So 1 phenyl meth, eth, prop. So propan 1 on or 1 phenyl propanone. this. When you have CO and CHO together, then the ketone is named as oxo. So the numbering will be 1, 2, 3, 4 and 5. Always remember there cannot be any terminal ketone, because if it is in the terminal position, then the fourth bond is ought to be H, which makes it aldehyde. So this, when oxo is there, that means when aldehyde and ketone is there, the ketone is named as oxo. So this is 3-oxopentanal. Now this one again, 1, 2, 3, 4 and 5. 2 position there is a methyl, 4 position there is a methyl. So 2,4-dimethyl. Pentan, 3 position there is one, pentan 3 one. So this one, this is carbon number 1 which has CHO, and this is carbon number 4. So 4-nitro benzene carbaldehyde, or you can say 4-nitrobenzaldehyde. Benzaldehyde is also known as benzene carbaldehyde. So if you have more than one CHO group, then you are going to name them as carbaldehyde only. So not only in the ring system, if you have more than one CHO, you name it as carbaldehyde. So this is 1, 2 and 3. So propane system, 1, 2, 3 tricarbaldehyde. Okay. So next, this is the table. Here we'll see formaldehyde, methanol, all these things you can see isobutyryldehyde. These you have to remember the common names like acetaldehyde, formaldehyde. These common names are really common actually. So this one, 3-methyl cyclohexane carbaldehyde. So this is 1, this is 2, this is 3. So this is like alpha methoxypropionaldehyde. That means what? This is 1, this is 2, this is 3. So this is the functional group. Carbon atom 2 is your alpha carbon, alpha position having the functional group. There you have OCH3, so alpha methoxy. And propane system having aldehyde at carbon number 1. So propanaldehyde. That's why alpha methoxypropionaldehyde is the common name. IUPAC is 2-methoxypropanal. Okay. So valiraldehyde is pentanal. So these common names. Acrolein, double bond is there. So 1, 2 and 3. So prop 2 in 1 al. Phthalaldehyde means benzene, and this is 1 and 2 dicarbaldehyde. So again, ring having CHO. So it is benzene carbaldehyde or benzaldehyde. 3-bromo, 1, 2 and 3. So ketones are like this side. This is methyl and this is N-propyl ketone. So it is C double bonded O. One side there is methyl and the other side it is N-propyl. So how will be the naming? Giving less number to C double bonded O. So 2, 3, 4 and 5, and it is pentan 2-one. This is 2,4-dimethyl pentan 3-one. The similar manner. Alpha methyl cyclohexanone. So this is the carbon having the functional group. Okay, C double bonded O. So this is the methyl. So 2-methyl cyclohexanone, 1 and 2. Mesityl oxide, very famous. So here it is 4-methyl. So this is 1, this is 2, this is 3, this is 4, and CH3 like this, whole twice, 4, and this will be 5. So a pent system, 4-methyl pent, 3N2-one. This is a vowel, so you will say 3N2-one. Okay. Next, structure of the carbonyl group. Carbonyl linkage is like this. So this carbon atom is sp2 hybridized, and this is a polar linkage. Oxygen having delta negative, carbon having delta positive. This is a polar covalent bond. Oxygen electron density shifting more towards oxygen, making this delta negative. So when this is a negative, when this is delta negative and delta positive, this is your nucleophilic site and this is your electrophilic site, which is electron deficient and is also known as Lewis acid site. And this is known as Lewis base site because it is having excess of electron. Now, here we can see in a C double bonded O linkage, what is happening? C double bonded O linkage. This is a sigma linkage, this is a sigma bond, and here sigma and 1 pi. So what will happen? These are the sigma planes. These are the sigma planes. And there is a pi bond formation like this. Above and below the plane like a banana bond. So the pi cloud is above and below the trigonal planar. So it's approximately 120 degree and it is a trigonal planar structure. Pi cloud is above and below the plane. So pi electron cloud is above and below the plane. So this is it. And coming to the in-text question little later, let's see the nomenclature part of the carboxylic acid again. Oic acid I said. So this is carbon number 1. So methanoic acid, formic acid. This is ethanoic, this is propanoic, butanoic, always number them. It's also known as butyric acid, isobutyric. Iso linkage is this linkage. We have seen so many times iso linkage. But means 4 carbon atoms, so butyric, this is it. 2-methyl propanoic acid, so 1, 2, 3, 2 position methyl. Now Ohm's gap, I have told you, this we can see Ohm's gap, oxalic acid, malonic acid, succinic acid, glutaric acid, adipic acid, and the last one is palmitic acid. So this one is Ohm's gap, having total of 2 carbon atoms, see 1 and 2. This is 1, 2, 3. So I said remember Ohm's gap for dicarboxylic acid containing total 2, 3, 4, 5, 6 and 7 carbon atoms. Okay, so this is having a CHO, another CHO and another CHO3. So we'll name it as tricarbaldehyde. So leaving the COOH, my mistake, it is not CHO, it is COOH. So leaving the COOH, you will have to number it. So 1, 2, 3, propane system and tricarboxylic acid. Okay, so here it is. This is benzoic acid, so benzene carboxylic acid. And here we can see phenylacetic acid. Acetic acid is CH3COOH is acetic acid. You replace one H by a phenyl group. So this is phenylacetic acid. So it is 1 and 2 position having phenyl, 2-phenyl ethanoic acid. Phthalic acid is benzene 1,2 dicarboxylic acid. This is the structure of carboxyl group where we can see the carboxyl linkage is not same as the carbonyl linkage because the lone pair above oxygen goes into resonance and C double bonded O is no more a C double bonded O. It is having a partial C double bonded O character on account of the resonating forms. On account of the resonating forms. So for that reason, it is not a complete C double bonded O. So what happens? The bond length of carboxylic acid C double bonded O is not as short as a carbonyl. It's in between a C single bond O and a C double bond O having a partial double bond character. Now the in-text question, two in-text question we need to see. Draw the structures of alpha methoxypropionaldehyde, total 3 carbon atoms. 1, 2, 3 carbon atoms. Alpha methoxy, that means CHO is attached to this carbon and so this is alpha. Methoxy means OCH3. So this is alpha methoxypropionaldehyde. Next, 3-hydroxybutanol. So meth, eth, pro, but. So this is a butanol system. 3 position there is hydroxy, and now you fill up in this manner. So that is it. See, 1, 2, 3 and 4. It's same as this. 1, 2, 3 and 4. Then 2-hydroxycyclopentane carbaldehyde. This is your cyclopentane carbaldehyde, and 2 position there is OH. Next is 4-oxopentanol. I told you that this is 1, 2, 3, 4 position C double bonded O, 5. Next, di-secondary butyl ketone. This we need to understand. A keto linkage is C double bonded O. Now both the side of the keto linkage, it's a 2 degree. Di means 2. 2 degree butyl system. Secondary butyl. This carbon is a 2 degree. How? This is 1 and this is 1. 2 degree, but it will be butyl. Meth, eth, pro. This is but. So this is again a 2 degree but system. There will be another carbon atom. So CH3, CH2, CH, CH3, H, H3, H2 and H3. This is the structure. Last one, 4-fluoroacetophenone. Now this is your acetophenone, and 4 position there is a fluoro. IUPAC names over here. Number it. 1, 2, 3. Having a phenyl. So 3-phenyl propanoic acid. What about this? Let us see. 1, 2, 3, and here there is a 4, and niche there is another CH3. So 4 carbon atoms, but. So 3-methyl but 2-enoic acid. Okay. Now here we can see IUPAC name. This is 1, this is 2. What is happening? This is 2 position. There is a methyl. 2-methyl cyclopentane carboxylic acid. Why carboxylic acid? It is attached to a ring. Here again it is benzoic acid we can see. But in the 2 position, 4 position and 6 position there are 3 nitro. So 2, 4, 6 trinitro benzoic acid. So nomenclature part and structure part is not very difficult. In the next session we are going to discuss about methods of preparation. Till then, bye all of you. Thank you all of you for viewing my channel, and I need your support, I need your likes, I need your shares and subscriptions. So do follow for more informative videos. Thank you.